Good morning, one. Myself, Shivraj Singh, Assistant Professor in Electronics and Communication Department, SIIT, Bhopal. Today, we'll be discuss about the source transformation method, which is used for the network analysis. Source transformation is a basically method to transform one source to another source. For example, we can analyze the circuit. So for simplicity, we can replace the one source to another source, like voltage source converted into current source. Yeah, suppose that current source are converted to the equivalent voltage source. So source transformation method in which we can convert the one source to another source. Electrical source transformation is a method of replacing voltage source in a circuit by its equivalent current source or current source by equivalent of voltage source. Basically, just source transformation technique is used to simplify the electrical circuit for the analysis purpose. That means if suppose that to find the response of the system across any element, then for simplicity, we can use the source transformation method in which we can convert one source to another source. Now, discuss about some source transformation rule. First one, voltage to current source. Suppose that we have one voltage source along with the series impedance or resistance. For this electrical network are converted into a current source. That means voltage source are converted to into a current source. So for this, we can convert the voltage source along with the series resistance into a current source along with parallel resistance, where I equal to V upon R. Second method is current to voltage source conversion. In this case, current source are connected along with the shunt resistance. This current source may be converted a voltage source by voltage source along with the series resistance, where V equal to voltage source must be equal to V equal to IR. Third one, if n number of voltage source, here only consider two voltage source. If two voltage source connected in series with the same polarity, then its equivalent represented by V equal to addition of voltage V1 plus V2. Similarly, if two voltage source in opposite direction, then in place of plus we can assign negative voltage as per the polarity of the voltage source. If fourth rules, parallel voltage. If n number of voltage source are connected in parallel, then it's equivalent to represented by a single voltage source. So here only two voltage sources are considered, V1 and V2. In parallel case, both voltages are same. Now, in terms of current, series current, if n number of current sources are connected in the series, then this is replaced by a single current source. That means in this case, I1 and I2 current are the same. If next one, parallel current, if n number of current are connected in parallel form, then it's equivalent to addition of the current. If they are same direction. If current direction are opposite, then they are subtracted. Next one, voltage source with parallel resistance. In this circuit, we can observe one voltage source are connected in parallel. So we already study in parallel circuit voltage are same. That means is in this case we are neglect the resistance and only replace the single voltage source. Next one, current source with the series resistance. If the circuit are connected like this one, that means current and resistance are connected in series, then same current flow through the this resistance. So its equivalent represented by a single current source, and in this case resistance is replaced by a short circuit. And in this case, voltage and parallel resistance are neglected. Next one, current source shifting. If there are two resistance or impedance Z1 and Z2, Z in this case Z1 and Z2, and it's parallel connected to a current source. So then same current flow through the Z1 and Z2. So this equivalent represented by this one. Z1 parallel to I1, yeah, I current. Similarly, Z2 connected to parallel in current source. Next one, voltage source shifting. If two impedance are connected parallelly and the voltage source are V1, then we can replace by a Z1 along with the series voltage V1 connected overall parallel circuit to Z2 and series voltage V1. There are some example related to source transformation. How can find the response of the circuit response with the help of source transformation rule. So here some example are discussed. Example, here we can solve this circuit. That means to find the response of the circuit across 8 ohm. That means we calculate the output voltage across 8 ohm by using source transformation rule. So in this case, firstly remember all elements are connected in parallel by using source transformation rule. Second one, element are not changed if the response find across them. So here 8 ohm resistance, here fix the 8 ohm resistance due to find the response of the circuit response. Uh, Here we can observe 12 voltage source are connected in resistance, which is connected in series form. So here this voltage source is replaced by a current source. The current source 12 upon 4, that means 3 ampere, and connected 4 ohm resistance in parallel. This 8 ohm same. Again, simplify the circuit. Here 3 ohm and 4 ohm and 8 ohm are connected in parallel. So the parallel resistance are replaced by a 4 into 8 divided by 4 plus 8. That means equivalent resistance equal to 2.67. Again, simplify the circuit. This parallel combination current source and resistance replaced by a voltage source and series resistance. So this voltage source equal to 3 into 2.67. That means 8 volt, and resistance are connected this one. And here the load resistance are 8 ohm. Now calculate the response across the this ohm. So we simply apply the KVL or volt according to voltage division rule. The voltage across 8 ohm resistance equal to 8 into 8 volt into this resistance 8 cross 8 upon 2 upon here upon 2.67 plus 8, that means 10.67. Here 8 cross 8 divided by, here we mentioned divided by 10.6, that is equivalent to 6 volt. These are the basic example of the source transformation rule. Next one, this one. Second example, using source transformation method, determine the current I across 2 ohm resistor. So here we can find the I across 2 ohm resistance. Then this circuit is simplified this one by this. The voltage source is replaced by a current source. That means 20 upon 4 equal to 5 ohm, and 4 ohm replaced by a parallel. Again 10 ohm same as 4 ohm and this one. Now we can observe 5 ohm and 10 ohm are parallel. That means 5 plus 10 equal to 15, and 4 ohm and 4 ohm are parallel resistance. This parallel resistance is equivalent to 2 ohm. 4 cross 4 divided by 4 plus 8 equal to 2. Now again this circuit is simplified due to current source parallel to resistance. Then this current source is replaced by a voltage source. So 15 into 2 equal to 30, and 2 ohm are connected in series. And this 2 ohm also connected this one. So by KVL or directly find the current I equal to V upon total resistance. That means 30 upon 2 plus 2 equal to 7.5 ampere. Thank you. These are some example